Hi everyone, good morning. Can you see my screen everyone online? Can you hear me? Can you confirm anyone?
Yes, I can hear you, Ram.
Yes, Ram.
Fine. Yeah, fine. So in the last session we discussed about SDLC, right? Software Development Lifecycle, right? So how the project teams are designing CI/CD, how the uh, code will be from one stage to other stage, how developers start development, right? Their local workspace. Once development is completed, what they will do? Developers they push the code to GitHub remote repository, right? So once the code is moved to remote repository, so in the flow, our next tool is Jenkins, which is CI/CD tool, right? So every tool we integrate with the Jenkins. Jenkins is the mediator tool. It will integrate all the tools, will communicate all the tools by installing plugins, right? In Jenkins, what we will do? We create jobs, right? So we create the jobs and we schedule the jobs. So as per the schedule, Jenkins will trigger the job. Once the job is triggered, what will happen? Yeah, the code will be pulled from GitHub to Jenkins, right? Once the code is moved from GitHub to Jenkins, yeah, the code which we pulled from GitHub to Jenkins, which is we can say raw code, right? Which is unstructured code, unformatted code. So that raw code will not understand by application servers, right? So that is why we require one more tool, which is Maven, right? So what is Maven? What Maven will do? Maven is a build tool which will generate artifacts. What is artifact? Yeah, artifact is nothing but archive file. Artifact is nothing but archive file. So archive file based on the application development. Like so, when we talk about application development, three types of developers will be there: desktop application, web application, and also enterprise application. So desktop application is in our local system, whatever applications are there like calculator, paint, paintbrush, right? These are all desktop applications, right? So if the application is desktop application, Maven generates which format? Jar, Java archive files. Okay. Yes. Yeah, normally, yeah, based on the technology. So even not only Java, .NET, ASP.NET, or else Python, Ruby, whatever, right? So respective format will be generated. Yeah. So if the application is web application in Java, WAR file, web archive file, right? If the application is enterprise application, it generates ER file, right? So based on the application development, Maven generates respective format, right? So once it is generated respective format, then Jenkins will take that and push to respective target web servers and deploy onto target servers, right? That will be happened in the live application. So non-live applications also, in real-time projects, normally non-live applications like which is not in live, right? Like HarshaTrainings.com, right? Yeah. For that non-live applications, the WAR file will be stored in the Nexus repo, right? So Nexus repository is one of the popular repository. So Nexus is specially designed to store our artifacts, right? So whenever we have release, so by the time Jenkins will take that and push to the target servers, right? Yeah, that flow is very very important, right? That is we can say build and release process or CI/CD process, fine. Yeah. So today we are going to discuss about servers and networks basics. Okay. So in this servers and networks, whatever terminology is there, that is very very important. Okay. So today, tomorrow we are going to work on this. Today we are going to work on servers. Takes 1 hour. Okay. Tomorrow we are going to work on networks. That takes 1 hour. Okay. So day after tomorrow we are going to start AWS. Okay. Yeah. Day after tomorrow onwards we require laptop. Fine. So if you understand these basics, today's basics and tomorrow's basics, that will help you to work in AWS. Same concept. These are the physical environments, but so same concept we use in cloud also, AWS also, right? Fine. So anyone newly joined today, can you share your WhatsApp number, email address in the chat so that I'll provide you previous recordings? So anyone newly joined today, so my mobile number is 96422111711. Can you share your WhatsApp number, email address here so that we'll provide you previous recordings, demo recordings. You guys, you can share your WhatsApp number, email address in the GoToMeeting chat. Fine. Yeah. So introduction to servers and networks. So agenda here is what is server, types of servers, server client model and best practices, server architecture, what is operating system, types of operating systems, what is network, types of networks, what is IP address, subnet, gateway, router, firewall, failover, load balancer. Right. So up to here we discussed today. Up to here. So tomorrow we are going to work on this networks and all. Okay. Yeah. So what is server? What is server? Anyone? What is server? Server is a computer. Server is having high computing power, right? So more memory modules like so in desktop or laptop we use only one memory module or two memory modules and one storage, one processor like that. But server side, number of disks will be there, number of processors will be there, number of memory modules also available, right? Yeah. See here, a server is a computer that serves information to other computers called clients, right? Server is a normal computer, right? That's yeah, that serves information to other computers called clients can connect to a server through either a local area network or wide area network such as the internet. See here, types of servers. So in physical data centers, we see these servers. Okay. First one is blade servers, rack servers, tower servers. Let us go with one by one. What is a blade server? A blade server is a modular server, yeah, that allows multiple servers to be hosted in a smaller area. So this is one container. Instead of this container, we can insert blade servers, right? So 16 ports blade will be there, and a 32 port blade will be there. So in that small servers you can insert. Okay. So these servers you can see in large data centers. See here. These servers are physically thin and typically only have CPU memory integrated network controllers. CPU memory integrated network controllers. What about storage? So these servers are very thin, right? Typically only have CPU memory integrated network controllers. But what about storage? So storage normally we connect external storage, okay, and sometimes storage also built in. Storage drivers also built in. So blade servers are often seen in large data centers like Google data centers, UHG, Verizon, AT&T, this type of large data centers. We use the blade servers because blade servers are bit costlier compared to rack servers, tower servers. Okay. Yeah. Next one is rack servers. A rack server is a server mounted inside of a rack. Rack servers are typically general purpose servers that support a broad range of applications and computing. Most of the data centers we use the rack servers only. So this rack servers are having 48 ports and 24 ports like that. So on each rack, 48 servers you can insert. So backside we can connect our network cards, network cables, power, right? We can start our server and we can take through ID rack remote and we can configure the server and we can move to production. Next one is tower server. This is a bit older server. A tower server is a computer that is built in an upright cabinet that stands alone and that is designed to function as a server. So tower server is a tower, only one server will be there in that. This is a bit older server. Okay. Next one, see here, client server model, right? So we use desktops or laptops to connect our servers through network, right? So when you give the when you send the request, server will respond. We give response. immediately. Okay, see here another client server model. So either we can use desktop or laptop or even tablets we can use to connect our servers through internet. Okay, next one, server architecture. So what is architecture? Server architecture is the foundational layout or model of a server. So based on which a server is created and are deployed, it defines how a server is designed. Okay, so when we talk about server architecture, let's try to understand here few examples. Server architecture, initial stage of implementation. So this we can say first phase of implementation. First phase of implementation, initial stage of implementation or first phase of implementation. Yeah. So in 1990s and early 2000, in 1990s and early 2000, how the server architecture would be, how the server architecture by the time. Okay, so in 1919 and early 2000, so the positives when they wanted to deploy different applications, how they used to design the servers. Okay, for example, four applications are there: Java, Python, Tomcat, and also we can say uh, other application like Jenkins, for example. So by the time Jenkins, it was not there. Okay, for example, so these four applications they want to deploy. Okay, so in 1990s and early 2000, how they used to configure servers. Okay, yeah. So by the time they used to take one server for one application. For every application, they used to take one server. Okay, so why they used to take one server for one application? We'll see that. So these are the four servers are available here. These four servers are having storage. So in 1990s and early 2000, highest storage capacity is 1 GB by the time in 1990s and early 2000. Okay, yeah. So 1 GB is the highest capacity of the storage. Okay, these are all 1 GB storage servers. Yeah. So here in the first server, they deployed Java. Java occupied 300 MB, for example. Okay. So remaining space 700 MB space will be wasted right here. 700 MB space will be wasted. Okay. Yeah. So second one, here they deployed Python. Python occupied 350 MB, for example. So remaining 650 MB will be wasted. Same way, Tomcat occupied 400 MB. So remaining space will be wasted here. Yeah. Same way here, Jenkins. So Jenkins occupied 500 MB, for example. So remaining space will be wasted. Right? Yeah. So in 1990s and early 2000, they used to take one server for one application. Okay. So here, by the time hardware costing, it was very higher, even a desktop or laptop costing also, right? So in 2000, in 2002, some yeah, 2002 or 2003, uh, 2002 I think. So Celeron P1, P2, P3 configurations, desktops. Okay, so one desktop cost 70,000, 80,000, like that we used to see. So currently 15,000, 20,000 also we are getting desktops, right? So by the time server costing too much cost. Okay, here what happened? So utilization is very less. Server utilization is less, costing very higher. Okay, so that is why, yeah, clients they used to spend more billing for hardware purchasing, right? So that is why. So this is the failed concept actually. So by the time they used to design like this, so one application, one server, right? So your costing is very higher, utilization is very less. That is why this is failed concept. This is failed. Yeah. So after a few years, in second phase of implementation, what happened? In second phase of implementation, so project teams used to take one high-end server. Project teams used to take one high-end server, only one server, high-end server. Okay. So they used to deploy all the applications on the same server. Okay. For example, here Java and Python, Tomcat, and Jenkins. They used to deploy all the applications on same server. Okay. So here four users are there. Four users are accessing four applications, right? So here Java user is accessing Java application. Python user accessing Python application. Tomcat user accessing Tomcat. Jenkins user is accessing Jenkins. Okay. So four users are logged into same server. So here what will happen? So this Java user may access Python application also. There may be chances to access. So Python user may access Tomcat also. There may be chances. Tomcat user may access Jenkins also. Because four users are accessing same server. Security will be there. But there may be chances to access other applications also. Right? Yeah. For example, four people are staying in 2 BHK flat. So two people are staying in one bedroom, other two people are staying in other bedroom. So the four people commonly access kitchen and dining room. The same way, people are accessing same server. There may be chances to access other applications also, right? That is one drawback. And also, one more important drawback is, so if the server is crash, what will happen? All the applications will be gone. That is all. Yeah, that is why this is also failed concept, right? Yeah. After that, after few years, in third phase of implementation, what happened here? Yeah, virtual servers came into the market. Virtual servers. Okay. So virtualization, we can say virtualization, virtual servers. Okay. So what is virtualization? Anyone? What is virtual server? Yeah, which is not physical one. It is a imaginary server. Okay. Virtually we can access, right? Yeah. So in virtualization, what will happen here? What we will do? We take one physical server. Okay. This we can say base OS, base operating system, base server, right? Yeah, this service having high computing power, right? High computing power, RAM, so 48 GB, CPU, 32 core, and storage, SSD or HDD storage like 10 TB, like this, highest capacity. Okay, yeah. So we take one server. On top of that, we deploy software like VMware or hypervisor or Citrix. These are all virtual softwares, right? VMware Hypervisor Citrix. Yeah. Once you deploy this software, what will happen here? This will allow you to create virtual servers. Yes. Like this. Right? So these are all virtual servers, 5 into 5 servers, 25 servers. Okay. So on top of the physical server, base server, we can create n number of virtual servers as per the physical server capacity. Okay. Yeah. So here we can deploy different operating environments like RHCL, Windows 2016, Ubuntu, CentOS, and also Windows servers 2022, right? So like this we can create different operating systems here. So 25 operating systems you can create in the 25 servers. So these servers will work individual, right? So these servers you can create and hand over to respective projects. Okay. Yeah. So currently also we're using virtual servers, but here also some drawbacks are there. What are those drawbacks? Okay. Yeah. So when you want to create any operating system, we require ISO image. What is ISO image? For example, if you want to deploy Windows on your laptop, how can you deploy? How can you install? You can copy one image into pen drive. That pen drive you can convert into bootable drive, right? So by using that bootable drive, you can set up your system and you can install operating system, right? Yeah. So when we talk about ISO image, this ISO full form is International Standardization Organization. It is a master copy, full blowing operating system, right? So this ISO image size would be minimum 6 GB to 18 GB. ISO image size 6 GB to 18 GB, right? So here on an average, uh, we have 25 servers right here. Each server is having 10 GB, for example, on an average. 10 into 25, 250 GB we need to spend for only operating system. So on top of that, we need to deploy applications, patches, plugins. It takes more space. That is one of the drawback. Okay. So storage costing higher here. And also when you restart, reboot, both are same. Restart server. It takes 4 to 8 minutes. So when you restart your server, it takes 4 to 8 minutes. So server, yeah, if you restart your desktop or laptop, so quickly within few seconds you can restart. But server side not like that. So when you restart server, it takes 4 to 8 minutes because will check memory updates. So slowly it will restart. So normally 4 to 8 minutes client will not accept for restarts, right? Yeah. So for example, Flipkart is running on his server. If you restart Flipkart server, it takes 4 to 8 minutes. What will happen? Business will be impacted, right? So backend cluster will be there, but normally it will be happen like this. Okay. Yeah. So 4 to 8 minutes client will not accept. That is also one of the drawback, right? And also deployment time and downtime is high. So deployment time. What is deployment time? Anyone? Yeah. When you want to deploy any applications, when you want to deploy any coding, right? So that takes more time. And downtime. What is downtime?
Stop the server for a few times. I mean, few seconds. I mean, was any other kind of what we call any work or anything.
Yeah.
So we need to stop the server for a few minutes or anything.
Right. Downtime is nothing but simply you can say maintenance time, right? So maintenance time also higher, deployment time and downtime is higher. These are all drawbacks. Still we are using virtual servers, right? But these are all the drawbacks. Okay. Yeah. So that is why currently we are using, yeah, in fourth phase of implementation we are using advanced technology. So in fourth phase of implementation, so we are using Docker containers. Docker containers. Yeah. So Docker containers are advanced virtual servers. Okay. Yeah. Fine. So let's try to understand first this architecture. Okay. So here I'm taking one server, which is we can say this is a Docker server, which can be which can be AWS EC2 EC2 instance. Yeah. This terminology is very important. So in AWS server we can call it as EC2 instance. In Azure we'll call it as server we can call it as VM. In Google Cloud we can call it as VM instance. EC2 instance, Azure VM, in GCP VM instance. This terminology is very important. Should not call it as server. Okay. Yeah. So either AWS server, AWS instance, or AWS EC2 or Azure VM or GCP VM instance. It can be any instance. Okay. Yeah. On top of this, what we will do? Yeah, we can prepare one image which is Docker image. Docker image. Okay. Yeah. So this Docker image allows you to create Docker containers. These are the Docker containers. Yeah. So here we can deploy different operating environments like Ubuntu, RHCL, CentOS, Windows, like this. Okay. So when we run any container, only in that container, only lib and bin files will be installed. Lib and bin files will be created. So when you run any container, only lib and bin means library binary files only available here. Okay. So here when we talk about ISO image, it is a full blowing operating system, full package of the image, right? But when we run the container, so here only lib and bin files. So once you run the container, it takes 200 MB of the size, 200 MB size only. Container OS size, container OS size it takes 200 MB. But whereas here 6 GB to 18 GB, on an average 10 GB. So why this much of drastic change here? Because only library binary files will be available in the container. When we run the container, only required files only. So both we can use for deployments, even virtual server or container. But containers are lightweight because very less size, 200 MB. Okay. Yeah, and also when you want to restart your container, it takes 15 seconds only. 15 seconds. When you restart container, it takes 15 seconds only. Very fast, very quickly. So even though the developers who are working on this containers, they will not understand whether it is rebooted or not. Okay, yeah, very faster. Okay, and also deployment time and downtime is very less. So deployment time and downtime is less. Okay. So when you want to deploy any applications, very quickly you can deploy the applications on containers. When you want to when you want to restart, when you want to reboot, so very fast it will be rebooted. Okay. Yeah. So these are all advantages of containers. Moreover, licensing costing is very less. License cost is less. So here what is happening here? So time will be saved, costing also will be saved. So very faster we can work on the we can deploy the applications, we can restart the containers, we can access the containers, right? And also licensing cost is very less. So client always look for the cost saving, right? So that is why currently most of the project teams they are migrating from virtual servers to containers. They are deploying their applications on containers. They are migrating applications to Docker containers because containers are lightweight, standalone, very faster, less costing. Fine, clear it everyone, online guys. Any questions up here, anyone? Up here, any questions, anyone?
Docker image refers to OS only, right? Docker.
Image master copy, that is master copy. Docker image is in master copy that will allow you to create the containers.
Yeah, it's an OS only, right?
Yes, yes, definitely. Yeah, online guys, I enable the mic. If you have any questions, you can ask. So after that, we'll jump into next slide. Fine. Yeah. So Docker launched in 2013, right? Yeah. So 2013 onwards, applications. Yeah. So project teams they started using digital applications. So online shoppings, like online shoppings, right? So currently, widely we are using so everyone using online shopping, right? Currently. So when we are booking any groceries or any gadgets, anything, right? So groceries they are delivering within 5 minutes, 10 minutes also, right? And even I booked one mobile recently, few weeks back. I booked one mobile, latest OnePlus mobile. They delivered within 4 hours. They delivered within 4 hours, right? Earlier, 3 years back, 4 years back, when we book any mobile, they used to take at least 1 week or 5 days time, right? So they deliver within 4 hours. So they have a locker warehouse here, Madhapur.
Yeah.
So immediately the request processed here, they deliver that, right? Yeah. So Docker launched in 2013. So immediately after 1 year, Kubernetes launched. Kubernetes. So what is Kubernetes? What is Docker? Docker is a container tool. Docker is a container tool. Kubernetes. What is Kubernetes? Kubernetes is a container orchestration tool. Advanced to Docker.
Both are same, but it is advanced.
Advanced to Docker. Yes. Kubernetes is advanced to Docker. Yeah. So Docker developed in Docker developed by Docker Inc. Yeah. Kubernetes launched in 2014, immediately after 1 year, because Docker is having clustering issues, cluster issues. So now it is fixed. Now it is working fine. But initially, Docker uh, creating cluster, managing cluster in Docker is very difficult. So that is why Kubernetes immediately After 1 year, Kubernetes released. Kubernetes developed by who developed this Kubernetes?
Google.
Anyone?
Google.
Yes, Google, right? And also Docker supports. These are the entry questions. Docker supports 95,000 containers. Okay, yeah. Kubernetes supports 3 lakhs containers. So Kubernetes also required containers. Without Docker, Kubernetes will not work. Kubernetes is having Docker dependency. So before installing Kubernetes, we need to install Docker first, right? So same Docker containers will work in Kubernetes also. But Kubernetes is having advanced features. So in Kubernetes, we can call it as pods. Pod is nothing but a group of containers.
Why Kubernetes should depend upon Docker?
Containers required, right? Containerization.
Because it is already have 3 lakh containers, right? It can capable it's having a capacity of 3 lakh containers.
Yes.
And it is having 95K only.
Hmm.
So why should it depend on Docker completely? It can have its, your own things, right?
Same, that 3 lakh containers, only Docker containers. Those are the Docker containers, not Kubernetes containers. Docker containers only. But when we deploy Docker in Kubernetes, what will happen? It supports 3 lakhs up to 3 lakh containers.
Okay.
Okay. Yeah. So Kubernetes is very hot in the market currently, right? So Kubernetes and Docker both are. So if you are good in either Docker or Kubernetes, you can easily crack your entry. Along with that, we required one cloud platform. Even Jenkins is also required. Jenkins is a heart for every DevOps engineer. Jenkins required. Along with that, advanced tools. So we are going to learn nearly 14 tools in our course, but all the tools we don't use in the same project, right? So my ex-colleague is working with HSBC recently. He joined. He got very good package also, nearly 42 lakhs. So Capgemini to HSBC, he moved recently. He got a very good package, 42 lakh package. Okay, so they are using only Kubernetes in HSBC, right? So one of my friend is working with Wipro. They are using Docker, Docker and Jenkins. Fine. So like that depend, yeah, project to project. Okay,
So
as per
Kubernetes
the
project also Jenkins is required.
Jenkins CI/CD. If you want to build CI/CD, Jenkins is mandatory,
Mandatory.
right? Fine. Any questions up here, anyone? So this Docker will go very deep dive. Docker takes nearly 10 days, very deep dive. Okay. So Kubernetes also will go very deep dive. So Ansible, Docker, Kubernetes, Terraform. These 4 tools are very core tools, right? Will go very deep dive. Even Jenkins also takes more sessions. Git will take 5 days. Okay. So like that, every tool will go very deep dive. Fine. Someone asking questions here. EC2 means ECMS script. No, no. EC2 is a elastic compute cloud, not script. Elastic compute cloud. It is a virtual server. We can say virtual server simply. Okay. Yeah. How about server data encryption with container? So if you want to encrypt, required encryption keys that will show you. You can enable the keys. Will it be more secure than VMware hypervisor Citrix? Yes. Containers are very more secured, right? So Docker is providing very good security. Network security also providing the Docker. So in the Docker, we have networking concepts also, right? So can we install Docker server in desktop? Yes, you can install on desktop also, but that is not recommended way. So always we are using cloud servers.
You install in servers only.
Sorry,
You install in servers.
server only. Yes, whether you can use physical server or cloud server, will work. System high configuration like 64 GB RAM. Yes, we can use Suresh. Jenkins and JFrog is same. No, not like that. So JFrog is Artifactory. Jenkins is CSU,
CSU.
right? So any other questions, anyone? Yeah. Can we install Docker server in desktop? Okay, desktop. They are asking desktop. Docker desktop also there. Docker desktop version also there. In our laptop also can install.
So that means our desktop is working as a server, kind of server. Means
Yeah. Fine. Easy to migrate VM to Docker containers. Yes, application we can migrate. Applications we can easily migrate. Fine. Yeah. So while working on Docker, we'll go very deep dive. It takes nearly 10 sessions. Okay. So Docker Swarm, Docker Compose, Docker networking, Docker containers, basic level, advanced level. So yeah, we have very good concepts are there in Docker.
Do we have any migration projects
Yes, yes, migrations also.
in our course?
Yes. So migration, server migration, data migration. You can see the projects are there. Fine. Yeah.
Uh,
Yeah. Go ahead, please. Go ahead, Amit.
so one question, sir. Here, can we say that Docker in itself is not a server? Rather, it is a kind of an application, kind of a platform, wherein actually it helps us to pull the server from the repository of the Docker. Let's say a Docker hub for us to manage different kind of applications, whatever the
Hmm.
server is being pulled from the repository.
Yeah,
So
yeah, Amit,
yes,
Amit, you understand? I understand your question, right? So Docker, Docker is a container tool. We discuss. What is container? Container is a just like box. So container we should not call it as server. It is a lightweight, just like box.
Logs.
We can move anywhere. We can use anywhere. It's a lightweight, like ship boxes. It travel anywhere. We can use anywhere, right? Yeah. So here, before Docker also, we used to use some containers. Before Docker also, we used to use some containers. Before Docker, what happened? We used to use some containers like LXC, Jones, LMCI, Fi. So these are the popular containers before Docker we used to use, right? LXC, what is LXC? It is a Linux container. Jones, it is a Solaris container. LMCI Fi, full form is let me container for you. This is a Google container. These three are containers. But these three are platform dependent containers. What is platform dependent, anyone? These three containers are platform dependent. What is platform dependent, anyone? Platform dependent.
Based on the particular platform, which will work.
This will work on the respective platform only. So LXC run on only Linux. Jones run on only Solaris. LMCI run on only Google. Right? But why the Docker is very popular?
Supports
Yeah,
all the platforms.
Docker is famous. So because irrespective of operating system, we can run Docker containers on any platform like Linux, Windows, Solaris, even Mac OS also. Mac OS also, right? So these containers are platform independent. These containers are, we can say, platform independent, right? So that is why Docker is very popular now. right? So these contests are failed actually. These contests are failed because these contests run on only respective platforms. So these contests are very popular now. These Docker contests are very popular now. So that is why every project team they are opting Docker containers. Fine. So clear, right, everyone? Yeah. Next one. This is the architecture. While working on Docker, I'll explain this. Okay. Yeah. Next one. What is operating system? What is operating system? Anyone? What is operating system? Anyone?
User and the system introduction.
Yeah. Fine. So operating system. It is a interface between user and the computer hardware. So computer hardware always understand the binary language. What is binary language? Zeros and ones. 000 001 100 111 like that. But human will not understand the binary language. That is why we require one translator, which is nothing but operating system, right? See here. So operating system is an interface between the user and the computer hardware. The hardware of the computer cannot understand the human readable language as it works on binaries, that is zeros and ones. In such case, we need interface to hardware and vice versa for effective communication, right? Yeah. Now, see here. So this is the operating system. We have hardware and user. So in between, yeah. So mediator is the operating system here. It will translate from hardware to user, user to hardware, user readable language to hardware. Okay. Next one, types of operating systems. We have first one is single user, single tasking operating system. So in this type of operating system, only one user can log into the system. He can perform only one task at a time. For example, which is MS DOS, very old operating system. In this operating system, only one user can log in. He can perform only one task at a time, right? Second one is single user multitasking operating system. In this type of operating system, only one user can log into the system. He can perform multiple tasks at a time, which is nothing but Windows, for example. So when we are browsing internet, we can run background audios. When we are working on any activity, we can run audios, right? So at a time, we can run multiple tasks. Fine. Next one is multi-user multitasking operating system. So in this type of operating system, multiple users can log into the servers. They can perform multiple tasks at a time. So for example, while deploying the application, developers log into the servers, testers log into the servers, DevOps engineers also log into the servers. They can perform their activities, multiple activities. So here, which is we can say Linux and Unix. So why we are talking about Linux here? In real-time projects, 90% of the servers we use Linux only. Desktop and laptops, Windows. But server side, 90-95% servers we use the Linux only. PowerShell is the interface actually. So Linux is the OS, backend OS. So Linux is very secure, no viruses, virus free, right? So Linux servers will not go slow down, no crashes, no costly repairs. So many advantages are there. While working on Linux sessions, we'll see that. Fine. So that is why most of the positives are using Linux servers. Fine, clear, right, everyone? So this networking concepts will start tomorrow. So this will take nearly 1 hour. Okay. So networking terminologies are very, very important. LAN, WAN, MAN, right? Firewalls, load balancers, clusters. These terminologies are very important. So tomorrow we'll see them. IP addresses, subnet mask, uh, gateways. We'll discuss tomorrow. Fine. This networking terminology, same terminology we use in cloud also. Fine, clear, right? Any questions here, anyone? Yeah. So the people who are not registered so far, you can register and you can add into WhatsApp group so that you will get all the information in the group only. So link may be changed very soon. Okay, already group created and people added in the group. So the course fee is 20K. We already discussed, right? If you are interested, you can make the fee and you can send the screenshot to me. so that I'll add into WhatsApp group.
Sir, how many days it will take from this
How AWS? AWS nearly 45 days. Nearly 45 days. So we'll go very deep dive. AWS each and every service, practical oriented sessions. So not theoretically. So we are working on all the sessions practical oriented. So more into practical. Okay. So these are critical, just terminology. So you need to understand the terminology. Yeah.
once AWS company, you are going to the doctor and
No. DevOps. We'll start DevOps. In the DevOps, so Git, Jenkins, Maven, Ansible,
all the
Docker,
tools.
all the tools. Yes.
So first
So
you will be completing the AWS, after that you will go to
yeah,
the DevOps.
DevOps. Yes.
So parallelly, we you will be teaching the GCP as well as Azure.
Yeah, that is actually weekend sessions I'm planning. Parallelly, weekend I want to complete because we can reduce the time, right?
Yeah.
Yes.
Yeah. So our course duration is 4 months. Trying to complete within 3 to 3.5 months. So weekends I can take the Azure and
Because the
GCP.
concepts are same only, only the interface we teaching.
Exactly. AWS, Azure, GCP, all the concepts are same. Terminology would be little different, right? Yeah. Sure. Prakash, sure. You can take my number. You can ping me after the session. I'll share with you course content. Fine. Yeah. So if you have any questions, you can ask me. So tomorrow onwards, tomorrow we are going to work on network basics. So day after tomorrow, we are going to start AWS. Fine. Yeah. So we can wind up here. You can take down my number. If you have any more questions, you can reach out to me. You can ping me. You can call me after the session. Fine. So if you need a previous demo recordings, you can ping me. I'll provide you. Fine. Yeah. Thank you all.